Zenith TV Resurrection / Repair Part 2. In our last episode, this has held up well. This thing's too good. I might just have to keep it. Okay, so we've confirmed that this set produces a fairly decent picture aside from having a vertical issue. I could try solving the issue by checking the vertical output oscillator vacuum tube. In all likelihood, this issue is bad capacitors in the vertical, so I'm just going to start the preparations for dealing with that and complete them after testing the tube. So I shoved over my K-Part 16E turnover changer project, which, aside from this lever piece breaking off due to someone installing a important mechanical linkage backwards on the changer, and my own incompetence for not recognizing that, works perfectly well on manual cycling. So at some point I'm going to have to figure out how to recreate the part that this busted off of in its entirety, including this piece, but for now I'm pushing that over and I'm working on the Zenith chassis. As we can see looking over the chassis, it is pretty much bone stock original and full of these white, in this case Cornell doubler paper caps that aren't necessarily the best thing to keep in. There are some other types of caps in here. There are maroon drops. They're very similar to orange drops, and if it's not in a circuit that's causing problems, which I'm pretty sure this one is not in a circuit causing problems, I generally leave those alone. There's also a bumblebee capacitor, and those are, actually there's more than one bumblebee capacitor. There's another one over here, and I consider bumblebee capacitors to be highly unreliable. We also have a little issue, which was when I was hauling this set out of the basement it was bought out of, I found this little cap which is supposed to be insulating the bottom of the high voltage rectifier, and you can see, especially if I zoom in, look at all that crud. Look at all this. It's hairy with dirt from the high voltage. So I'm going to first try cleaning it with glass cleaner to start things off, and it's clear that the plastic has leached plasticizer, which is essentially holding any dirt that's touched it. So we're going to get out the big guns. This stuff, the pour bottle. Not the spray bottle. The spray bottle I think might be a little bit different. And yeah, that's really getting rid of the dirt. This will also take paint off of painted surfaces and do other extreme things, so generally don't use it in places where cosmetic appearance is key. Like, I would and am using this to clean the plastic high voltage rectifier base insulator cup, but I would not use this or recommend using this on, say, the plastic cabinet of a tube radio where it could be seen, because it'll probably create a haze there that will be visually unpleasant. Now, I'm not going to go to the effort of cleaning the entirety of this, just tidying it up enough that I can feel okay about putting this cover on here to insulate against arcs. And that should be good enough. One thing to note, that metal ring that was inside there, if the television's been on within a couple of hours, maybe a little bit more, you don't want to touch that metal ring because you could get a pretty nasty shock off of it. Not lethal unless you have a heart condition, but it's like a really, really mean jolt. The meanest jolt you can think of, shuffling your feet across carpet and grabbing a doorknob. So generally don't touch that unless you've discharged the high voltage from it with the correct procedure, which I probably explain at some point in time in the future, but I don't need to address in this video. So yeah, this will prevent arcing. Let's have a look at the schematic. There we go, now we're focusing. So, the vertical multiplier vertical output tube is the stage that we are concerned with. The most likely culprit for the insufficient vertical at the bottom of the screen is this C1 100 microfarad capacitor here. Other caps that we should probably change while we're addressing the vertical circuit are C48, C47, C50, C49, and C45 and 46. K1 and K2 can also cause problems in the vertical. When K1 fails, you'll have rock-solid horizontal sync, but you'll have no vertical sync. You'll be able to adjust the vertical picture so that it rolls very slowly, but you won't be able to get it to hold sync in any meaningful way. K2 can cause weird things. It can cause collapse of the vertical completely. It can cause odd off-frequency behavior. It can cause strange nonlinearities in the scanning where parts of the picture are linear and other parts are bunched up at random. It can cause a variety of issues, and both K1 and K2 are somewhat prone to failure. They're ceramic capacitor-based parts that contain basically 2 resistors and 3 capacitors equivalent circuit. If they fail, replace them with the equivalent circuits shown for them. If they're still good, I tend to leave them alone though. So if you're paying attention in the schematic shot a moment ago, you'll have noticed that the capacitor C1 connects to pin 9 of the vertical output tube here. I traced the yellow wire to this terminal of this multi-section C1 and unhooked it because this tester gets easily confused and it was only a 1-wire connection. It says ESR is okay and capacitance is within more or less tolerance for capacitors of this age. However, that doesn't tell me anything about leakage. It also doesn't tell me if capacitance is holding up properly. Oh, that's wonderful. That's just what I wanted to do. Since I've already taken the landslide route of getting my Heathkit C3 out, I might as well hook it up and see what it tells me. Because this will test for leakage at rated voltage. -2 chassis, +2 capacitor. First we're going to just check for capacitance, roughly, to confirm our results. Let's set the switch to electrolytic mode. Let's just sweep capacitance. Okay, it is definitely testing a little bit high in capacitance. That's still within the very sloppy tolerance early electrolytics had. One quirk of the Heathkit C3 that is widely known is that even though the leakage test's lowest voltage setting says 25 volts, the people who designed this set the circuit up to test at 50 volts and made a typo in creating the dial scale that they never corrected. So this will test for leakage at full rated voltage. Well, I'll be a monkey's uncle. This cap is actually testing good. Okay, so that's not our problem. This is my perfect opportunity to just go through testing these old ceramic capacitors. Now, they'll sometimes be okay, just like electrolytics of this vintage will sometimes be okay. Just because something's sometimes okay doesn't mean it's not about to pop. And with capacitors, they're a lot more likely to be in that about to pop state than any other component. I think I will test the C48 vertical size cap next because I can. Let's just do an in-circuit test on this because we can. Okay, let's set the Heathkit to paper cap. And this is a 600 volt rated cap, so we can't test it up to its full rated voltage, but when these things go leaky, and this one certainly is testing like it's leaky, they generally leak at a voltage a lot lower than their rated voltage. Actually, there's two things I should do right now. One is I should hook back up that electrolytic capacitor that I unhooked earlier to test, because it's probably fine. Another valid approach if you don't have capacitor testers is I test capacitors by listening for the sound they make when they hit the waste bin after I've installed a new one technique. Checking capacitors by replacing them with good new parts is also a valid testing technique. Costs money, but it's a valid testing technique. Let's hook back up, and let's do another leakage test. Okay. So what we were seeing earlier was not genuine leakage, but rather a parallel leakage path from another part in the circuit that was in parallel with it. Unhooking it is showing no leakage. Well, let's check the capacitance value and see if it's still correct. It's pretty much fin tolerant, so this capacitor hasn't failed. I'm going to replace it anyway, though, because I really regard these white ceramics as less reliable than anything else in the set aside from the bumblebees. And I've already got one lead unsoldered, so why not? Okay, I don't know when it stopped recording, but next up is C45, a 0.0068 microfarad 200 volt cap. A bumblebee, which will be replaced no matter what, but let's just test it for the sake of education. Set this to the correct range. Okay. Yeah. This capacitor is basically open circuit. That or it's got very high leakage, because there's no definite eye opening at what would be the correct point, and I'm getting a tiny bit way above that. So that's a problem, especially considering the capacitor's out of circuit. Let's test it for leakage at 50 volts. It's leaking pretty bad at 150 volts, so that's a problem. And yeah, that's done. Okay, time for a new one. Okay, that cap's in. I'm kind of interested now in seeing if any improvement in the vertical has been had. So, got to figure out how to bypass the remote control connector. That would also be consistent with the later Zenith remote plug wiring, so I'm going to try that. And just in case I got it wrong, there is the metered and fused variac. So, if I've accidentally shorted the power cord, incorrectly guessing what I need to jumper to bypass the remote chassis, the variac will simply trip its breaker. It's a nice little 2-amp breaker, and there shouldn't be significant harm to the television. 41 volts, what are we at for watts? 33 watts. That doesn't seem like a short to me. So I'm going to just slowly run it up, but not as slowly as yesterday, because theoretically the electrolytics aren't going to go bonkers. Okay, we still do not have as much deflection as I would like. One goofy thing I want to do while the set is still on is I just want to verify that that 100 microfarad cap that tests good isn't giving me a false good test. So we'll just stick another 100 microfarad in parallel with it and see what happens. This other microfarad is rated at a higher maximum voltage withstand level, so even if the cap has higher voltage on it than specified, the replacement shouldn't do anything bad. It'll probably spark when I connect it. No change. Okay, so it's definitely not that cap that I thought it was at the beginning. We're going to switch to resistance tests. So one of the quickest ways to check K1 and K2 is simply to measure the resistances across the resistance element of those networks. If they test significantly outside of what they're supposed to, then you know something is not right. It's 43 kilo ohms. K1 is supposed to be a couple of 33Ks in series. That's a pretty low resistance. But it does have other resistors in parallel with it. Yeah, I'm going to test the other K network, K2, before I think about K1. K2, where's the equivalent circuit for it? 247Ks in series, and it's testing at 87. That's basically within tolerance. So K2 is probably fine. Or at least not ridiculously bad. Let's check capacitance of that part. This is going to be fairly inaccurate and inconclusive, but this will just give me some insight into what to think about this. It's like that. Is it symmetrical? That's what we care about. Is a symmetrical reading that seems reasonable. Not testing symmetrical on that side. Well, that could just be the resistor next to it. Let's just take the resistor out of circuit and find out. Capacitance is reasonably symmetrical. It's fine. That's a 10% 68K resistor. I think that's out of tolerance, but let me check my math. 68 times 1.1. Yep, that's out of tolerance. Okay. That's enough to tell me that I want to replace that resistor. That's swapped out. We have a leg lifted is the best time. And I'll also check that and replace that white Almenco. That's closest to the capacitance it should be. What's its leakage look like? Leakage isn't bad, but again, this is yet another cap that I just ought to replace for principle. Okay, since I don't have a .015 in my parts stash, what we're going to do is put a .01 and a .005 in parallel. Capacitors in parallel, the capacitance adds. Okay, so I've chased down all the vertical stage resistors, and I've only needed to change two, the 68K in the vertical feedback loop, R64, and the 4700 ohm in the vertical output cathode, R67. Those two were outside of factory tolerance ratings. And I tested the set, and it hadn't changed operation characteristics significantly. I then played with the vertical linearity and height, and was able to expand the raster some without a test pattern, so I don't know exactly how good of linearity it has, but it's still not completely filling the screen. Let's check the final remaining original capacitor in the vertical circuit, ignoring electrolytic cathode cap for the output, which we've already confirmed is fine, both by tests to the capacitor and by bridging an identical capacitor across it. This remaining paper cap is one that couples into the grid of the vertical multiplier tube. It is a 400 volt .022 microfarad C46. Let's just check for leakage, and ooh, it has leakage. It has a lot of leakage. It's leaky down to 150 volts. Well, that was probably our vertical circuit culprit. I'm going to have to change that cap now. That's pretty clean. And we found our defective capacitor. This Cornell Doubler Bud Rock. Sounds like a beer. With luck, the set will produce a full screen raster now. Let's see what it does. Haha! Full screen raster. I just have to adjust the vertical with a test pattern and I should be done. Okay, so I'm about to hook up my test pattern generator to the tuner. And what is this electrical tape on the twin lead antenna input? What in the heck is this? Who's the moron that cut the and put it? That's great workmanship right there. How many inches did I lose from this wire from whoever did this? I have to see if this even reaches in the cabinet. If it doesn't, I'm going to have to replace this lead entirely, and if it does, I'm going to have to clean up this mess. I just love 60-year-old hack repairs. That just makes my day. Let me get the TV on. Okay. What channel are we set to right now? 3 is the channel. Okay. Okay. So Lin affects the top. Let's try height. There we go. That's pulling the bottom in. Centering up a little bit. That's not too bad. I'm going to grab a test pattern with a circle on it. My agile modulator. I'll turn that off. And okay. Brightness. That's pretty good vertical linearity. The picture tube's on its side, so vertical is this axis right now. Horizontal linearity, which is this axis, is a little bit off on that side. Schematic of horizontal section. What saith you? No horizontal linearity control. Okay. Does the width sleeve do anything beneficial? Not especially. It's not bad. I think I'm going to replace the 2 bumblebee caps that remain in the set, and then possibly the remaining 5 white ceramics, and clean the tuner and call it good. So going through recap for reliability. This bumblebee cap here the eye does not fully open and does not do so at the correct value on my capacitor tester. So this 0.068 200 volt bumblebee is also leaky. The eye should stay open when I switch to leakage mode and it's closing, which that's badly leaky. It's not leaky down at 50 volts, but at 150 volts, which is close to its designed operating voltage, it's pretty much shorted. That's 2/3 of the bumblebee caps that are unusable. And another failed white ceramic tubular. This one is a 0.047 200 volt cap. Right now we're on capacitance mode, and at almost double capacitance is the only eye opening, the only faint eye opening. And on top of being basically an open circuit, if we test it for leakage at 150 volts, that's shorted. That cap's done. I'm kind of impressed it worked with that cap like that, because that cap is not in the vertical stages, and the other stages didn't seem to have noticeable performance issues. Just because a set works on original parts doesn't mean the original parts in the set work. Okay, we're down to two capacitors, well, two non-electrolytic type capacitors left that we need to change on the main TV chassis, and this 0.033 microfarad 200 volt cap is not well. There is no eye opening at all on capacitance, and it's shorted at 150 volts, and it's even shorted down to 50 volts. Yeah, that cap's pretty much a dead short. Amazing this thing worked on so many bad capacitors as it's had. And the last paper cap, a 0.1400. It is also defective. It is leaky at 150 volts, and at 50 volts that thing's basically dead shorted. The eye does not fully open on capacitance and is at opening at a significantly higher capacitance than what the capacitor should be. So that one's bad too. These Zeniths are pretty tolerant to bad capacitors. It's kind of surprising. So if you've got a set that's been sitting unused for years, maybe decades, and the tuner contacts have gotten really dirty and disgusting, I'm going to show you how to super clean your tuner. Now, one easy and cheap way, particularly on these drum style tuners where the contacts are on channel strips that are exposed and easy to get at, is you can take a white eraser and just rub the contacts, and that's the anybody can do this way of contact cleaning a tuner. Now, if you want to super clean it, get yourself a can of this stuff. WD-40 will work in a pinch, but it's not ideal. And just kind of, there's two ways you can do it. You can spray the contacts down. I don't like getting excess contact cleaner in the tuner, for reasons I'll go into shortly. Or you can just spritz your eraser a little bit and run the eraser over the contacts. And now you're cleaning it with two methods at the same time. And that'll clean it up extra good. A good way of cleaning the eraser is if you've got like a wooden workbench that's like made of 2x4 like mine, you can just kind of scrape it on the surface of the 2x4 and it'll grind a lot of the gunk off the eraser. Now there are also tuners that have a different style of switch assembly. Do I have one to demonstrate? Sort of, kinda. Get over here. Now, there are tuners that have wafer switches in them, sort of like this, but a lot more compact, a lot more components packed around them, and a lot tighter of a can. A lot of those you can't really get an eraser in to reach the contacts because of how densely everything's packed. On those tuners, you take your tuner cleaner, and you really want to use proper tuner cleaner, or deoxit or deoxid, don't use WD-40 if you can at all help it. Just spray the contacts down. Try not to use excessive amounts of cleaner or spray any coils or tune components. And then just grab the tuning knob and spin it around 2-3 times one direction, spin it around 2-3 times the other direction, and that should clean up your contacts. On drum tuners like this, you can clean a lot better, but it's a lot slower because you have basically 13 contacts in an average drum tuner that each have to be rotated to, cleaned, rotated to the next one, cleaned, and rinse and repeat till you're done. We're missing a strip right here. This might be for UHF. An interesting thing on remote Zeniths is you could get them with a separate full frequency UHF tuner that would tune the entire UHF band, or on remote sets you could get channel strips. There, I believe, were only a maximum of 7 channel allocations in VHF that could be used in any major city. So if you lived in a major city that had a couple of UHF stations and you had a remote set and the remote sets didn't have motorized UHF tuners in this time period, only the VHF tuners are motorized, so you could replace channels that weren't used in your locale. You could replace the strip for, say, if channel 5 was unused, you could replace that strip with a UHF strip corresponding to a local UHF channel. Zenith was actually quite brilliant in their tuner design. Every Zenith tuner until 1964, when UHF was mandated on all tuners, every Zenith tuner, going back to their first sets, had provisions for UHF channel strips in the tuner design. Even though Zenith was producing their first sets in 1948 and UHF wasn't standardized until, as a commercial broadcast format, until 1952, I believe, they had provisions in all of their early tuners for UHF channel strip conversions. Now, the channel strips would be set to only tune to one specific channel, and you would have to buy more than one channel strip if you wanted to tune more than one channel. I haven't ever owned any Zenith channel strips, but if they were anything like the ones RCA used in their CT100, 21 CT55, those two color sets, and several of their monochrome sets, the UHF channel strips could actually be retuned over a fairly broad portion of the UHF band if you opened up the tuner and adjusted adjustments on the strips for that. Looks like I've come around and cleaned the entire drum. I'm going to, as sort of a final cleanup, spray down a paper towel with some contact cleaner and just run it over the drum to knock off any remaining bits of rubber or other dirt that might be in here. And so this is the final replacement of the paper capacitors on this set. I'm going to put the chassis back in the cabinet and give it 2-3 hours of runtime, hopefully continuously, and check the electrolytic capacitor temperature during that time, and if the electrolytics stay nice and cool, I'll declare the main chassis good. If any of the lytics start warming up, however, then I'll probably come back and do some electrolytic recapping as well. So, here's the result of the chassis recap work on the Space Command Zenith. Looks really good. There's a little bit of RF noise because I don't have an antenna hooked up, but you can also see there is dot crawl in what should be the colored sections of the test pattern. It's a monochrome set, so it can't demodulate the chroma detail. You can adjust the fine-tuning to eliminate that, but that you can see the dot crawl means this set has very good high-frequency IF response, and is capable of producing a very detailed monochrome picture. A great way to watch one of these sets is to take a video source that has S-video output and modify an S-video cable so that only the monochrome signal is present. S-video is basically two sets of coaxes. One carries the monochrome video in sync and the other carries the color information. Normally the two are combined together for composite video, but S-video separates them for better recordings on Super VHS and Super Beta VCRs. Tom, Super Betas didn't come with S-video. Well, extended definition beta, which is kind of Super Beta, did. It's Super Beta because it's better than Super Beta. Let's get some picture and sound going on the screen and show off the performance. So it's working good. Volume stepper's now working. Mute's still not perfect, but it works okay. Channel functions work. I'm not really worried about the electrolytic capacitors on this set failing and causing damage. There's a fuse between the cathode of B+ rectifier and the first filter cap. If any of the main filter capacitors fail, they should blow the B+ fuse. Any significant damage in the event of electrolytic failure. It looks like there's a similar fuse on the remote control chassis. Part of me wonders if I should take out the remote control chassis and change the paper caps on that. Although it does work pretty good. And that should protect the set from... If I put this set into regular service in one of my main display areas where it's plugged in 24/7, I definitely will look at the remote chassis, but for now this set's probably not going to see a lot of use and is going to mostly be stored in my collection, waiting for a day when I'm moved into bigger digs with more space to display stuff like this. This set also represents in my collection the first all-tube remote set I have. Zenith, a few years after this set was produced, around 61 to 63, somewhere in there, they redesigned their remote hand units from this style to this style right here. And when they did that, they also redesigned the remote receiver chassis from being vacuum tube chassis to being solid-state chassis, and reduced the static power consumption from something like 30 watts to something like 2 watts when the set's off but the remote is in standby mode. There was a power efficiency mode for these sets to keep the remote circuit from drawing power when the set wasn't on. Simply turn the set off with its main power switch, and you get the center dot, which will happen anyway. You can't turn the set back on with the remote, or really do anything with the remote while the main power switch up here is turned off. But if you turn it on, you can turn the set off with the remote. And if you turn the set off with the remote and then work this control, it doesn't do nothing. If the remote fails and the set is turned off, there's only one way to turn the set back on. And it's this little switch right here on the back of the remote control chassis. You can see the remote control chassis is still powered on while the set's off. Well, if you turn this switch from automatic mode, which it's in, to manual mode, the remote chassis will turn off and all of these tubes will go dark. And I'm going to have to glue that sticker back on. Oops. And the main television chassis will come on. So as you can see, the remote just lost power and the main chassis is now getting power. When this switch is turned off, I do believe you lose, actually you don't lose motorized tuning. That's interesting. When that switch is off, the remote obviously won't do anything, but the TV becomes fully functional as a regular manual-controlled TV with power tuning. So I'm going to let it run for a few hours and see how it does, and if it does well, I'm going to bolt it back up and store it away for a while. The set survived playing a couple of movies without any heating of the electrolytic capacitors, so I'm going to call it good for now and store it away until I've got a good place to display it and use it. So this concludes part 2 of the resurrection of the Zenith Coburg. If you enjoyed the video, please leave a like, and consider subscribing for more content like this. Also leave a comment, let me know what you think. Thanks for watching.